Alrighty, let's get started. For those of you that are here. So, we are on week 3. There's no class on Tuesday, 4th of July, but you still got to do the assignments. Right? The assignments all have to do with just loops and ifs and elses, just practice of the same stuff. Alright? So, I'll just leave those unless you have any questions. Any questions about any of them? Okay. All right. So if you look at them and if you have any questions, let me know. I'll help you out. So what I'm going to tell you today is about functions. All right. And there's a chapter 4 in there from the Savage. There's some video that I have. And there will be another video today too. So let's have a look at what I have in here if I want to recycle some of my old stuff. I'll just leave it there. Alright, so let's say that you have some repeating lines of code. Alright, here's my one line, another line, 4 lines of code, right? And then later on, you decide to reuse the same 4 lines of code. So if I run this thing, you know how it's going to look like, a bunch of stars. Okay, but these lines of code are repeating. So what I'm going to do is I'm going to find a way to recycle them using a function. So the way I'm going to do a function is first, this is your function prototype. Okay, so this is going to tell the computer or the compiler there's going to be a function with a specific name. So this one is going to be void, I'll call it stars, just like this. And that's all the rest here, right? And by the way, the main is a type of a function. The main is the function where the program starts. Okay, so in here, wherever I use these, so this is my prototype, and wherever I had these, I'm going to call my function. So this is my function call, and then in here also I'm going to do another function call, stars. This is your function call. Okay, and now where's my definition for the function? Function definition. The function definition is pretty much the same as your prototype, except we don't have a semicolon. So stars, and then we add curly brackets just like the main. And I'm going to throw in these things in there. So wherever there used to be stars or these 4 lines of code, I'm going to execute, I'm going to call the function and then execute whatever's inside my function body. Right? So I guess you could say that this is your beginning of the function body, and right, that's the end. So anything that's inside of the function, right? Anything that's inside of the function gets executed when we call the function. So everything in the function definition is executed. Okay, so when I run this, it will look the same exact thing. Okay, so that's a basic example of a function and what a function is doing. Okay.
You have to define it up top.
You can actually move the definition. You can move this up here. But then you're going to be running into issues like if you have multiple functions and they call each other, you have to have one of them defined before the other one. So in order for us to avoid that, we're just going to have prototypes, like prototypes on top and then definitions on the bottom. So definition is under the main. Okay. This way, it doesn't matter in which order you have these functions; they'll all be able to see each other. Okay, so this is a basic function which does not return anything. So this void business here, void means the function does not return anything. Okay, in contrast, this is the main, right? Int main returns something. So int is an integer, so it's going to return an integer. Okay, so prototype, definition, function body, call, right? That's the terminology so far. So now the next thing that I'm going to show you is a function which takes a parameter. So I'm just going to call it, I don't know, add, okay, or show number, okay, and I'm going to have an int num in there, and this here, this is called a parameter. Okay, what is the parameter? It's the variable that will accept the value that we will pass into the function. Okay? So how is that going to work? It'll work like this. I'm going to go in there, I'm going to do something like show num, and I'm going to give it some value. Okay, as soon as I call my function, this value is going to be sent over, and this parameter, this variable, will become equal to that. Okay, so as soon, or when I call this function, num becomes equal to 10, right? The argument, the parameter num becomes equal to 10. Parameter. Can't even figure out how to spell it. Parameter. There you go. Okay. The value that we're sending, this here, is called argument. Alright, so it's important for you to know these terms, because the program a lot of times will tell you some errors like, oh, you had 2 arguments and you gave it 1, right? That kind of stuff. So basically, if I go in there and let me try to do, so this stars here did not have any parameters, right? And I'm going to try to give it an argument, and automatically you're going to see that this thing tells you too many arguments, right? So if you don't know what an argument is, you can look at this all day and you're not going to understand what it is, right? If you try to run it, compiler is going to give you some kind of a error like this: no matching function for call to stars, right? So basically, I have stars with 1 argument, I have stars defined as no arguments, I can't possibly call it like that. Okay, and actually it even tells you right here with some more. Candidate function not viable, requires 0 arguments, but 1 was provided. So if you know what an argument is, no problem. Otherwise, these errors are not going to make sense. Okay, so the argument is the value that we're passing into the function when we call, and then parameter is the variable that accepts that value. Okay, so I haven't written the show num yet. Right, so I'm missing the definition, so I'm just going to grab this, I'm going to copy it, I'm going to throw it right here on top of this, take out the semicolon, and I'm just going to do cout num equals, in quotes, num equals num, and del. Okay, so I'm going to do one call with a 10, then I'm going to do another call, and let me make a variable, int a is equal to 100, and then I'm going to say show num a. Okay, so a is the argument, it's a variable, but we're not passing the variable itself, we're just passing the value that's stored into the variable. Okay, so we are passing the value that is stored in variable a. Okay? There's ways for us to later on pass the variable itself so that we can change it and that kind of things, but I'm not there yet. Okay, so let's have a look at it. I'm going to go in there, try to run this one more time. And there you go. 2 different function calls. That's one function call, that's another function call. Okay, any questions?
See, the main program always had this return 0 at the end.
The main program has a return 0. Notice how it right here it tells you process finished with exit code 0. You can pipe, like basically in Linux, you can tell one program, you can feed the output of one program into another program. So this is a way to tell the next program that might be using this program that this one is finished successfully. It doesn't have to be 0, and a lot of times you can even get rid of it and it will still work. Right, but some more pickier compilers will give you an error message if you don't have a return. Okay, but it doesn't have to be 0. You can go in there and make it -99. Right, and then when I run it, process finished with exit code 157. So the negative 99 is not exactly showing as what you want it to, right? But basically the 0 is to tell it success, we finished good.
So a function being a subset doesn't require it, it's just the final end of the program.
Yes.
Okay.
Okay. All right. So now that you're asking me about returning, let me show you a function that returns a value. So let's say this one here is going to be void return value. I'm not going to have any parameter. Okay, just to keep it basic. Oops, no, it's not going to be void. Actually, let me try to do it as a void. Right? I'm going to do void. And here I'm going to say void return value. And I'm going to tell it just return 10. Okay, and right away it's going to complain because returning in from a function returning void, if I try to, let me try to see if it throws a fit right here. Yes, it does. So void function, this is the actual compiler error. Void function return value should not return a value. Right? Remember how I told you that void means the function does not return anything. So I can't use void. I'm going to say int. Right? Just like I have my int main, that's int return value. I'm going to change this to int return value. And what don't you like? Oh, now it's happy. Okay. So now I'm going to call the function. Let's say I'm going to call it right here, return value, just like that. Okay, and when I run the program, you're going to notice that it's not going to show anything. Okay? Why is it not showing anything? Because this function is returning a value, but where is that value? I'm not showing it. So let me show you how you can call that function. So calling a function that returns a value, I can call it straight from a cout like this. Whoops, no quotes. Right? And then when I run it, there it is. It's returning a value. Okay? There's another way to do it. I can say something like int return val is equal to return value. And then I can say cout return val. Okay? Let me throw an endo in there. And there. Okay, so if I run this, you're going to see 2 tenths. Okay, so that's a function returning a value. Any questions? So you can return integers, you can return, let's say I want to do average. All right, so this one is going to be now, so in here, int is the return type of the function. Right, means returns an integer. Okay, you can return a string, you can return a character, you can return a float, a double, all these different data types. So let's say I'm going to do a double. I'm going to call this average, right? And I'm going to have, I don't know, here I had an integer parameter. Let me make a couple of double parameters. I'm going to call this A. I'm going to call this B, right, semicolon, and I'm going to throw the definition right in there, take out the semicolons. Let's say I'm going to have a double average is equal to A plus B, the whole thing divided by 2, right, and then I'm going to return my average. Okay, avoid having variables with the same name as your function names, right? So I don't want to go in there and say AVG. That's not a good idea because how would it know which one's what? Okay, so don't do that. So no variables with the same name as the functions. All right, so now double, let's call this. So I'm going to say, all right, cout the average of 10 and 20 is average AVG 10, 20, and an endl at the end. If I run it, there you go. Okay, any questions? So you can return double, you can return int, you can have the function that returns not have any parameters. You can have the function have multiple parameters. Those are basically the functions. Any questions? It's just a way to recycle and reuse pieces of your code. Okay.
Any of your variable definitions can be a function.
What's that?
Oh, you went through a whole bunch of variables in the beginning of the class. Any one of those can be called as a function. Int, double.
You mean for the return type?
Yeah.
Yes.
Mhm.
All the different data types like int, double, right? So this again. So double means return a double. Okay, a function can also return int, char, string, float, double. Right? Those are the ones we covered pretty much. So all those can be a return type. Okay. So now that I have told you these things, right? So what are the terminology one more time? Void. What is a void? Means it doesn't return anything. What's a parameter? Parameter is the variable that we put in between the parentheses. What is an argument? Argument is the value that we're passing into the function, right? It doesn't have to be a value itself. It could be a variable. We're still passing the value of the variable into the function, okay? So those are the basics. Now some other things that have to do with that. Let's see what I want to tell you. Okay, so local, global, parameter, scope. So I already told you what's a parameter. Now let me tell you what's a scope. So let's say in here I have a variable int a, right? I have declared it, right? Let's say I'll do it this way. I'm going to say int num, right? So what is num? Num is a local variable, right? Local means it was declared inside of a function. And a local variable can only be used inside of the function where it was declared. Okay? So the scope of the variable num is int main, right? So the scope means the scope refers to where the variable can be used. Okay, so the variable int was declared inside of the variable num was declared inside my main, and that means that all these other functions have no idea what this num is. Okay, if I go in there and I say, oh, hold on, let me just do a cout num right here. So this one does not have a num, right? I'm going to just try to return num like this. And you automatically can see that this does not like it. cline doesn't like it. If I try to run it, use of undeclared identifier num. And you're going to say, well, hold on, I declared it up here. That's fine, but this is a local variable, so this function here has no idea what num is. Okay? So if I just try to do something like cout num equals num, right? You get the error. Let me copy it. Right? This is the error that you get. Okay? Okay, so you cannot use a local variable outside of the function where it was declared. Okay, so that's scope, local variables. So what kind of a variable do you think these are? Is this a local variable?
Other parameters that pass through, right?
Yeah, but do they belong just to this function? Can I go in there and say this? Let's just try it. So cout a, or a is equal to a. And nope, right? Same business. It will tell you the same exact error like before. If I run it, right? Blah, 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 use of undeclared identifier A. So, right, parameters, so this parameters A and B are local variables, okay? So just like a variable that was declared inside of the curly brackets of a function, a parameter which is declared inside of the parentheses of a function is also local to that function. Okay, they're local. So what is the scope for these two? The scope of A and B is only the function average. Okay? Does that make sense? So it's important for you to learn these concepts. What's a scope? Well, it's where it can be used. Okay? So now you know what's a local variable. And let me show you an example of a global variable. Okay? So normally what we want to do is we want to have our variables local. We do not want to present the ability of one function to be able to change the variables of another function. Because maybe you're working on a big team and you're going to be developing one function to solve one problem and somebody else is going to be developing another function that solves another problem, but then that somebody else accidentally goes and messes up with your variables and now your function doesn't work. So you want to hide these, okay? And that's why you don't want to have global variables. But I'll show you what a global variable is with the condition that you don't get to use them. All right? Ever. Don't use them in this class. Okay? So I mean, if you're going to have something like a constant pi or whatever, that's one thing. But generally speaking, don't make global variables, because you would be tempted to say, well, I don't need parameters. I'm going to make all my variables global. Saves me work. Okay? So I'll show you what a global variable is. All right? So global variable is a variable declared before and outside of other functions. Okay? So what is the scope? Scope of a global variable? The whole program. Like the scope of a global variable is the whole program. Right? Program, so it can be used and changed by all the functions. So any function that I have, if I declare a variable, I'm going to call it int global variable. Okay, I'm going to make it equal to 0 here. Right? I can go in my main, I can say, oh, well, hold on. Global variable is now equal to -1. No problem. I can go in this one here, right? I can say, well, global variable is equal to 100. No problem. Right? So I can change my global variables in any one of these functions, no problem. Okay? Because the scope of the global variable is the whole program. Questions? Okay. So you know about the different return types, you know about parameters, you know about global variables and scopes and local variables. And again, keep in mind that parameters are also local variables. Their scope is only the function where they were defined. Let's see what else I want to tell you. So, yeah, what's a void, all that good stuff. That's not a whole lot, so let me close it. Yeah. All right. So,
How do you see that a variable is defined as global versus just a regular variable?
how do you know if the variable is declared? Well, if it's declared before your function prototypes
Or not in the main?
and not in the main or in any of the other functions, then it's a global variable.
Okay, so it's just location.
Yep. before all the other stuff. And outside, before and outside. Okay, so these are the basics of functions, okay? And then later on, I'm going to show you different things like, well, how am I going to be able to change things? Let's say, I'm going to show you an example. So let's say in here, I'm going to say void no change. And I'm going to say int x, okay? And just for kicks, I'm going to go, let's say, in here. I'm going to throw that in there. I'm going to say just x is equal to 100. Okay? And now what I'm going to do is, in here, I'm going to make a variable x, and I'm going to make that equal to 0. And I'm going to show you, cout x is equal to x, and L. And then in here, I'm going to say no change, and the name kind of gives it away. I'm going to say x. All right, and then after that, I'm going to do another cout to show you what x is. So what do you think is going to be the value of x when I do this?
100.
So the name did not give it away. All right, so if I do this here, let's run it again. You see, the value of x does not change. Okay? So even though I have a variable x here, and I have another variable x here, and they're both called the same thing, they're actually different variables, right? You can actually show yourself the memory addresses of x. I can do cout %x. Let me put a label. Memory address of x, and I hope it doesn't mess with me, because C++ is just a pain. Okay, and L. So memory address of x in the main is this, right? And then I'm going to copy this, and I'm going to throw that here. I'm going to say memory address of x in no change is this, right? So let's have a look at that. I don't know if you can see them, but if I zoom in on this a little, see, that is a different number than this one. So if you imagine RAM has thousands and thousands of little memory slots, right? And there's one memory slot which has this particular number, and there's another memory slot that has this particular number. Okay, they're both referred to as x, but one is not the same as the other, right? They're two different places in memory. Okay, so changing one memory location does not change the other memory location, right? So I guess if I open up Excel, all right, so let's say you have your memory address, right? So I have, this is one memory address, and then this is my other memory address, right? So the first memory address is in the main, right, which is this x right here. And so this is my memory address, and this is info in memory. Okay, the information that's stored in this particular memory address is 0, right? The information that's stored in this particular memory address is 100. Okay, they're both variable name. They both have the same variable names, right? They're both called x, but they're not the same memory address, right? So if I go in there and I change this one, which is what I'm doing right here, it does not have any effect on this one. And then I will show you how to do pointers, and pointers is a way for you to basically make this one here point to the memory address of this one, but we're not going to do that today. Okay? I'm not going to overwhelm you with too much stuff. Okay? So these are the basics of functions. Now you know. Again, keep in mind, this right here, right? This is a local variable. It was declared right here. It cannot change this particular variable in another function, even if you called the variable in that other function the same thing. Okay? Because this particular x is local to this. This particular x is local to my main. Okay? So, what do you have to do for this week? Smallest, largest, I'm just going to go through all of them again. Alright, smallest, largest, sum and average. I already gave you an example the previous week on how to do that, right? Okay, so I'm not going to go over that again. Gymnastics score. Let's have a look at that thing. Alright, so you're going to write a program to compute a gymnastics scores. There are 4 judges who mark the gymnasts in the range of 0 to 10. The overall score is the average of the 4 marks. Okay, an error message should appear if a mark is entered that is out of the range from 0 to 10. And that's it. Do you have any questions on this? You need a hint on this? Or we're good? Anyone want a hint? Going once, going twice. No hint. Okay. So, practice arithmetic. It has to do with random numbers. I already showed you how to make random numbers. Now what you're going to do is you're going to make two separate random numbers, and you're going to ask the user to find their sum, product, or difference. We're not going to do, division, because you're going to have to, make sure you put in the exact number of decimal points. So let's not go there. So simple addition, subtraction, multiplication. Okay. The only trick is if they get it wrong, right? So let's say, for example, this is your sample run. You ask them, would you like to add, subtract, or multiply? Let's say they want to add, and you're giving them 2 plus 2, and they can't figure it out. They're giving you the wrong answer. What you have to do is your program has to repeat the same question again and again and again until the user gets it right. And that's it, right? If they get it right, you tell them, would you like to try again? And you can take them back all the way to the beginning, I guess. Let me edit this a little bit. I'm going to copy this. So let's say they want to try again. And again, you present them with the same thing. Would you like to add, subtract, or multiply? They still want to add. They still can't figure out their math, right? 3 plus 8 is 3. No, you give them the same question again. Let's say again they get it wrong, right? This time they give you like a 10. And again, you're going to tell them the same question until they get it right. Once they get it right, you ask them, would you like to try again? If they don't want to try again, you stop the program. Okay? Questions? We all know how to do this? All right. You sure? Positive? 100%?
Do you make the operands show up randomly?
You mean the plus and minus?
The 2 plus 2?
The numbers themselves, yes, are going to be random. These numbers are randomly generated. Okay? So that's that one. Save that. Next one, penny that doubles or $1 million. Alright, so you're presented with a choice between $1 million today or the future value of a penny which doubles its value over 30 days. Which one would you choose? You trying to do the math in your head? 16, I can hear it. 2, 4, 8, 16, 32. All right, I'll tell you what do you think is the value of that penny at day 30? All right, at day 2 is 2, at day 3 is 4, then it's 8, then it's 16. At day 30, the penny is $5 million. FYI. Okay? So now you know. So you're going to write a program which shows you the values of the penny for 30 days. So it's just a loop that happens 30 times. Inside of it, you have a variable that doubles its value. And then you're going to see it. At day 30 is like $5 million. And you're going to tell the user how much more or less they're going to get if they, pick the $1 million. Okay? So that's that. The next one is the dice. Okay, so you're going to write a dice program, again 2 random numbers, and this time you're going to ask the user if they like to keep those. So you make two random numbers for two dice. You ask the user, do you want to keep those? If they don't want to keep them, you let them roll again. If they still don't want to keep them, roll again. If they still don't want to keep them, roll again. Okay? Any questions on that one? Okay, so if you have mastered the basics, it should be a piece of cake. And if you haven't, you would be very lost. Okay? So again, you have to work through these problems. You can't skip any of them. And if you did all of the assignments, at this point, you should be able to do this. Okay? That's why I'm not going to provide too many hints on this. Okay? And then you have a quiz that has to do with the Chapter 2 homework from that one of the chapters. I think it's this one, computer hardware. Yeah, there you go. So from this Chapter 2 are going to be all the answers in this quiz. You can take it multiple times. If you don't do well on the first time, take it again. Look at the answers. Okay? I don't care. Just make sure you get a good grade on it. All right. And what do we have to do for Thursday? Thursday's assignments are similar to what we had to do already. This one is write a program which asks the user to type in three numbers A, B, and C. You're going to ask you to let the user know if A squared is equal to B squared plus C squared, or B squared is equal to A squared plus C squared, or C squared is equal to A squared plus B squared. Right? We're trying to see if it's a right triangle, basically. Okay? You can also check to see if the three numbers are equal. So let the user know if the three numbers are equal. And if it's neither one of these two cases, just tell them neither. Okay? So basically the first one we can use to find out if given three sticks, the thing is a right triangle. The second one will be if it's an equilateral triangle. And I guess the third one is like some other kind of a triangle. Okay? Questions on this? Keep in mind, I'm not giving you the exact syntax on how to write this. You can't have an if A equals B, B equals C all in one line. You're going to have to follow the proper format, right? It's going to be if A equals B, ampersand, B equals C, right? To make sure that they're all equal. Same thing here. You can't go into your, C line. You can't do, I guess this is your hint for 32. P32 hint. Let's say you have I don't know. You can't go and do C out A squared like this, right? If I try to, or let's make it 10 squared. I'll make it an A. So this is an A, int A, right? And I'm going to make 8 is equal to 10. And then in here, I can't just go and say A to the power of 10 like this, because that's not how it works in C++. The easiest thing to do is just do A times A. Okay. You can import a math library and use the power function. There's a power function that you can use now that you know what a function is, but don't bother. Just use this. That's good enough. Okay? So there you go. So that's the power. So to use power in C++. Okay? And that's that. So next one, 33. Okay, 33 deals with ASCII. Okay, and you already had to write one program, I believe, where you had to do 1,000 lines, right? So many of them per line, that kind of stuff. Do you remember that? Some of you are nodding the head. Excellent. The rest of you, I hope you remember that. All right, and if you don't remember that, I guess I'll give you a hint. All right, so here we go. So you have, and I have given you some hints in there. So basically, it goes like this. You're going to show me all these different characters, and how are you going to show me these characters? You're going to look at the ASCII table. So I'm asking you for character, the exclamation, all the way to the tilde, which are, the exclamation is 33. Right? That's this one. You can't see it. Maybe if I zoom in enough, you still can't see it. It's in there, believe me. This is the exclamation, right? Which is number 33, and it will look a lot better on your screen than it does on this, right? So the exclamation is 33, and then we have a whole bunch of other characters. The last one that you're going to show is the 126. So you're going to show me ASCII characters from number 33 all the way to number 126. And you're going to be showing them whatever, some certain number per line. So how are we going to do this? Let's have a look. So I go in there, and let's say this is your hint for 33. P33 hint, right? So let's say I want to do the ASCII values for, I don't know, from 33 to 47. So I'm going to go for I in, oops, wrong language, for int I is equal to 0, I is less than, oops, not 0, 33 to, I don't know, let's go 47, right? So 47 including, and then I plus plus, whoops, and then what I'm going to do is I am going to show you the I first. So C out, just I on a new line. I'll put it on the same line, just like that. So I'll run it, and this is what it shows you, right? 33 through 47. Now what I have to do is I have to convert these integers into a character. I think, let me have a look at the syntax here. You say char, well, let's do it now. Let's add another one. So I'm going to make in here, I'm going to make a variable int char, char letter. All right? Now I'll call it symbol. Okay? And then in here I'm going to say symbol is equal to I. Okay? And instead of I that I was showing, I'm going to grab this thing and I'm going to show you symbol. And now I'm going to run it again. And now you see that it's showing you the different symbols. Okay? So I converted my ASCII, right? What I'm doing here is convert my ASCII number to an actual symbol. Okay? Now the next thing is how we're going to show them so many per line. Let's say I want to, I don't know, suppose I want to show, I don't know, 4 characters per line. Okay? I'm going to go in there, I'm going to make myself a count variable. Count is equal to 0, right? The purpose of this is to count each variable or, I don't know, symbol shown. So every time I do a C out, I'm going to say count plus plus, right? If my count becomes equal to, I said I want 4 of them, 4 per line. So if I counted 4 of them, that is when I'm going to introduce a new line, and L, right? And if I run it, it'll work fine for the first 4, and why is it not working for the rest of them? What is the value of count when I show the first one? 1. What about the second one? 2. Third one? 3. Fourth one? 4. What about this one? 5. So it's never going back to 4 again, which is why it's not going to show another new line. So what do I do to fix it? Make it equal to 0. So I'm going to go in there, I'm going to say count is equal to 0, which is basically telling it to restart counting after showing a new line. Okay, so it's very convenient for you if you write yourself little comments in there and explain to yourselves what your programs are doing. Okay? If you don't do that, you know, don't expect to be able to look at your code later on and to understand what it's doing. You write a lot of comments. Okay? Just like I'm doing. Okay, so that's the hint for number 33. Next one is, now we're going to do some functions, right? So this is basically the end of the practice of the things that we've been doing. Now 34. Alright, what is 34? Ooh, that one's hard. Alright, so you're going to write a function with a name crosses and a parameter num crosses, the function outputs as many rows as there are crosses. Right? I will have to give you a hint on this. Right? So it goes like this. So let's say I'm going to write it in here. So this is P34. P34. Hint. Okay. So let's say I wanted to show this kind of a business. I'm going to copy it, throw it in there. Ugh, that's horrible. Right, so you know what I'm going for, right? So let's say if I want to show this, so when num crosses is 3, right? I want to show something like this. Ugh. Right, so I want to show, I'll just do it single line comments. Okay, I want to show 1 star, then 2 stars, maybe a little space, and then 3 stars, right? If I change this thing to 4 crosses, right, then it should show me 1, 2, 3, 4. Okay, so how do I do this? So what I'm going to do is I'm going to show you how to do it because it requires a nested loop, and then your job is to throw it inside of a function. So, and then if you can do it without looking at my hint, great. I would love to see that. Okay, that's the problem solving that we're going for. So let's say I'm going to have an int num crosses. That thing is 4. All right. The first thing I'm going to do is I'm going to say, all right, 4 int I is equal to 0, I is less than num crosses, and then I'm going to say I plus plus, and I'm going to go cout, and I'm going to show a little asterisk, and followed by a new line. Right? So if I run this thing, and maybe I should do another endl at the end. So let's do a cout endl here. One more time. Right? Maybe 2 of them. Alright? So these are my stars right here that I created. So what am I doing? I am making this column of these stars. Okay, but I'm still missing this piece here. I'm missing this one, I'm missing this one, I'm missing this one. Okay, so instead of I'm just going to call this line. All right, line, right? The reason I'm changing it to line is to show you that when so at line 0, we're going to add 0 stars. Right? When I go to the next one, at line 1, I'm going to add 1 star. Right? At line 2, right, I'm going to add 2 stars. Right? I'm adding 2 extra stars. At line 3, I'm going to add 3 stars. Okay? So what I'm going to do is, I'm basically going to do this. I'm going to do a cout, right? If I just leave it like this and I run the code, it still looks the same. Okay? But basically, what I'm going to do is, I'm going to add extra stars for every additional line before showing a new line. Okay? So I'm going to go in there, I'm going to make another loop for, let's call it, I don't know, extra, or not, int I, I'll call it an I, is equal to 0, while I is less than my line. So this loop, the line from this loop, is going to affect how many times this loop happens. Right? So the first time we go through the loop, line is 0, this is not going to happen at all. Second time I go through this loop, line is going to become 1. That means this loop is going to happen 1 time. Okay? So I plus plus. And then in here, I'm going to throw another curly brackets. And I'm just going to add some extra stars. Right? So I'm adding, show as many extra stars. Show as many extra stars as the number of line. Okay? So now when I run this thing, hopefully it works. And it looks like this. Okay, you want to add a little extra space. Maybe I should do that here. Let's try it. There you go. Let's not. No extra spaces. There you go. Close enough. Alright, so if I have 4 stars, if my num crosses is 4, I get this thing. If I go and I change it to 3, I get this thing. I go and change it to 13, I get this thing. Okay? And for extra credit, you can try to flip it upside down. So that it starts with this and then reduces. Now that I have shown you how to do this. Okay? And of course you have to throw this inside of a function, but the hard part is just figuring out this nested loop. Okay? Try to do this without the hint. Only look at the hint if you really, really get stuck on things. Okay? So that's number 34. And that one's actually, I don't know why I put it first. That was the hardest one of these. Okay, the rest of them should be pretty easy. Let's have a look. 35. Alright, write a function with the name is even. The function returns a Boolean value. The function has an integer parameter named number. The function returns true if the integer is even and false if the integer is odd. You can consider 0 to be an even number. Okay, so this is your function prototype. Alright. So let me give you a hint on something similar. So you remember how to do odd and even, right? I hope so. P35 hint, right? Remember, if num modulus 2 is equal to 0, then num is even. Okay, that's one of your hints. The other one is, let's say I'm going to have a function called I don't know, cout is positive. So I can show you how to is positive like a -10 or something. Okay? I haven't written this positive yet. That's why it's complaining about. So I'm going to go up in there. I'm going to write my, alright, so this is your, which one was this one? 35, P35 hint. Alright, so I'm going to have a Boolean. And this one is going to be is positive, and it's going to take some number, and I'm going to get this thing, copy it, throw it after my main to do the definition, right here, curly brackets, get rid of the semicolon, and then in here I'm going to say if my number is less or bigger than 0, right? I am going to return true. I hope it takes it true. Yeah, it likes true. Okay? And otherwise, else, I'm going to return false. Okay? So this should give me, remember, true is 1, true is 1, and false is 0. So when I run this thing, it better give me a 0, and if I go in there and I do it again, let me put an end out. Alright, I'm going to change this to a 10. Alright, so this I'm going for a 0, and this one here I'm going for a 1. And it's a good idea for you to, before you even run the thing, have an idea of how it's supposed to work. So be able to predict what's going to happen with your program so that when you run it and it doesn't work the way you thought it would, you know, you can easily detect it. Otherwise, you're just going to be staring at the thing with a blank look. Okay? So there you go. The first one is a 0, just like I expected. The second one is a 1, just like I expected. Okay? So that's your hint for this, for the odd and even. Next one is function with 2 parameters which returns a float. Alright, write a function that returns a float value of the larger of its 2 float parameters. That should be pretty easy, right? You have an if in there. If one is bigger, return that one. If it's the other one, return the other one. Okay? And by the way, let me show you how I can shorten this code here a little bit. Alright, so this was one way to do it. Alright? Another way to do it is, I'm going to get rid of the curly brackets. because it's a single line. If you have a single line, single statement inside of the if or the else, right, you don't need curly brackets. Right? So that will be the other way to do this. And it will work the same. If I run it, I'm still getting the 0 and a 1. And there's actually a way to shorten that also. So instead of doing this thing that I have on top, which is perfectly acceptable by the way, I can say return num, let's do it this way, num is bigger than 0. So remember, this here is a condition. The computer is going to evaluate this to either true or false. Right? So if it's true, it will return a true, and if it's false, it will return a false. I don't have to do this. Right? Run it. Same thing. Okay? How can I use this? In here, I can go in there and I can do things like, all right, I can say if is positive -10. Right? I can say, and another way to do this, I can just say is equal to true, right? I can do it this way. I'll show it to you two different ways. Cout, and let's get rid of the curly brackets because I want to shorten this. Cout -10 is positive, right? And of course it doesn't have to be -10. Let's call this y is equal to -10. I'm going to feed the y in there. -10, oops, y. Okay, why don't you like... Yeah, expression can be simplified. That's what it's telling me. I'll show you how to simplify it. Okay, and the other one is going to be else. Let's call this y. All right. This is negative. Right? So I go in there, run it. Forgot my semicolon. Run it again. Right? Y is negative. Right? So that's one way to do it. Another way to do this is if I went in there and I said is positive y. Just like that. Okay, so whether I do it this way or I just do it this way, this function returns true or false, right? So I don't have to check to see if it is equal to true. It will either be true or false. So I can just call it right from inside of an if. And there you go. Y is negative. Let's switch it to positive. Y is positive. Okay? So the more of these functions you write, the more you're building skills. You're putting different tools under your belt so that you can easily reuse them for your code later on. So you can build a library of functions, and then you can import your own functions. Just like we've been including this kind of a stuff here, you can actually create a header file. That's what these H files are. You can create a header file in which file we're only going to have the function prototypes. Every header file is connected with a CPP file, in which are all the function definitions. So it's a way to organize things. So all my function prototypes would be inside of a header file, and then all my function definitions, which you see underneath the main, are going to be in my CPP file. So if one is called functions.h, the other one is going to be called functions.cpp, right? And I'll show you how to do this kind of stuff in the next class you take, which is the CSIS 46, data structures. Okay? All right, so this is your hint for this was P35. Yeah, I think it was still P35 hint. Okay, so the larger one is pretty basic. And the last one, function with 4 parameters. Right? How does that go? Write a test. The following function, it returns the average of 4 parameters. It should be a piece of cake, right? It turns a float, takes 4 float parameters, divides, adds them up, divides by 4, and returns the thing. Questions? Okay. So that's what I have for today. And I'm going to post the lecture notes and the video for your viewing pleasure. If you have any questions, let me know. And that's all I have.